Hi everyone, how are you today? Today I'm going to show you how to use Scilab to solve this problem. fxy equals to 10x squared y minus 5x squared minus 4y squared minus x to the power of 4 minus 2y to the power 4. Okay, if you look at this problem here, what is this? What is this problem? So this is nonlinear due to the power of x squared for variable x and y. So we have two variables here, x and y. Okay, so for this nonlinear problem, also this is actually a two-dimensional nonlinear equation. So to solve this, how can you solve a two-dimensional system of nonlinear equation? We are going to use Newton method. Okay, so this is our goal. Okay, to use Newton method, so the Newton method formula is given as x, the current x equals to x, the previous value of x minus, now we have the Jacobian inverse x n minus 1. Okay, the inverse of this multiply with the function of x n minus 1. Okay, so this is the Newton equation, but remember you can get the inverse, but if you want to use Scilab or MATLAB, I can also show you how you can using a backslash notation to solve this. Okay, so if you want to put it in Scilab, so I'm using Scilab now. Okay, so you can, as easy as this, minus Jacobian x backslash. So this notation here means backslash f of x, which is similar to this inverse notation. Okay, or you can also do it like this: x equals to x minus inverse of Jacobian x multiply with function of x. Okay, now look at here, this is the initial value. Okay, but we want to update the x all the time, so we don't have to put any of this subscript n and n minus 1. Okay, now how do you find this? Okay, if you look at the question here, the question have x and y variable, and we need to find j. Okay, I didn't say what is j. J is the Jacobian matrix. Okay, for two-dimensional, there's two-dimensional x and y. For two-dimensional system, Jacobian matrix will be a 2 by 2 matrix. Okay, so Jacobian consists of the derivative of the given function with respect to x and y. Okay, so before you find it, you have to write it in two-dimensional equation. So I can start with partial x over partial f over partial x. Okay, when you have more than one independent variable, okay, you need to write the partial symbol here. Okay, if you have one independent variable, then you differentiate like normal. Okay, taking the derivative respect to x, so that's give you 20xy minus 10x minus 4x3. I'm taking the derivative of this with respect to x. There's no x, okay. And then taking the derivative with respect to y. So partial f over partial y. So now I have taken the derivative of y, okay, so which is 10x squared. Okay, there's no y here. What about this one? We have 8, negative 8y. And then minus x4. And then what about here? We have negative 8 y to the power 3. Okay? Okay, so we have written the function f here as a system of two-dimensional. Okay, now moving on. What you need to do here, so I always recommend you to write this as f1, write this as f2. So your Jacobian for this x and y, remember I say for a two-dimensional system, so your Jacobian will be a 2 by 2 matrix. Okay, your Jacobian will be a 2 by 2 matrix. So the first column here, the function of f1 with respect to x. The second column here, the function of f1. Okay, f1 again with respect to y. And then the second function of f2 with respect to x. And then function of f2 with respect to y. Okay, so this is called the Hessian matrix. Okay, this is also known as the Hessian matrix. Okay, so taking the derivative of a function, the first function with respect to x. So I have 20y. There's no minus 10 minus 12x2. Okay, and then look at the first function again. Take the derivative with respect to y. So I have 20x. Is there any more y? No, that's it. Okay, now looking into the second function here, taking the derivative with respect to x, I have 20x. Okay, now taking the derivative with respect to y, I have negative 8 for this one. 3 times a negative 24 y2. Okay, so this is your 2 by 2 matrix. Okay, now we want to put all this information on Scilab. Okay, I want to show you how can write this in Scilab first. Okay, so first we see that we have two variables, x and y. Okay, so for simplicity, I'm going to denote this as x1, this as x2. So that in Scilab, so when I'm using Scilab, my x1 notation will become x bracket 1 and my x2 notation will become x bracket 2. Okay, so similarly for the Jacobian here, it will be y will become my x bracket 2, x will become my x bracket 1. Okay, if you can understand that, then we can move on to writing the function file first. Okay, so what is the function? So function y equals to f of x, where my function of f will be a 2 dimension, so it will be 2 by 1 vector. Okay, so I have y equals to 20 times x1 times x2. Okay, what I've done here, this one, 20 times x1, because my My x is my x1 and y is my x2. Okay. Continue writing them. Minus 10 times x1 minus 4 times x1 power 3. Let's check. 10 minus 10x minus 4 times x power 3. Okay, that's it. And then separate with the semicolon to go to the second row here. So where we have 10 times x bracket 1 minus 8 times x2 minus 8 times x2 power 3. Okay, so let's write it. 10 times x1 squared minus 8 times x2 minus 8 times x2 power 3. Okay, so let's check. We have 20 times x1 x2, which is xy, minus 10 times x1 minus 4 times x power 3. Okay, and then move on with 10 times x2 minus 8 times y, which is my x2 power 3. Okay, so this is my function y, and save at f. Okay, so file, when you put save, it will go f.sci. Okay, now want to move to another function, which is the Jacobian. Write it as y equals to Jacob x. Okay, so Jacobian, remember Jacobian is a 2 by 2 matrix. Okay, this is my Jacobian. It's a 2 by 2 matrix. So when you see y, you write as x2. When you see x, you write as x1. Okay, I just want to tell you that. So we have 20 x2 minus 10 minus 12 times x1. Okay, so y equals to 20 times x2 minus 10 minus 12 times x1 power 2. Okay, separate by a comma because 2 by 2 matrix. So we have 20 times x1 and then semicolon to go to the second row. 20 times x1 comma for the next column minus 8 minus 24 times x2 squared. Okay, so this is my Jacobian. Let's check. So we have written minus 8 minus 24 y2, which is x2 squared. Okay, nice. So this is my Jacobian. Save it as Jacob. Make sure the names are the same. Okay, it's a function file, so it must be .sci. Okay, now moving on to the Newton method. So before I do that, let me just execute this button and then execute my Jacobi button here. Okay, so moving on to Newton.sci. So this is where we want to key in your value. Okay, so let's say x equals to input, enter the values of x. Okay, remember x must be a column vector. Okay, and then n. Okay, input, we don't have to do the enter the number of iterations. Okay, let's put a space here. Okay, now what we need this this file here. Okay, don't show remove it, but yes, this is what I need. Okay, x equals to x minus Jacobian backslash f. Okay, that's what you need. So in a for loop for I equals to 1 to n, x equals to x minus Jacob, that's what you call for your function, x backslash f times x. Okay, so then what happened here? So okay, we'll leave it like this. So we can if you put disp display x, what happened? It will just give you the final two solution. Let me just clear the screen. Okay, so by putting a run button here, okay, it's asking enter the value of x. We know x is a vector, so let's put a column vector 1 by 1. Number of iteration, let's say 5. Okay, so this is what we get. Okay, don't worry about that. Let's try again. You can also write it like this: 1 1 semicolon, enter 5. Okay, so there's two ways to write the values of x. Is like this, or with the semicolon but don't have transpose. Okay, this is the final, the last n value for the 5th iteration. We don't want that. So if you want to store it as a vector, what we do here, we can say my big X equals to bracket. We want to say the X is it's going to be all the values of up to n. So my big X equals to my big S, comma, small x, and then display my big X. Okay, what this means here, all these values will be shown. When I click the button, run. Oops. Okay, enter the values of x. So I have this one, number of iteration, 5. There you go. See that? So I have first iteration, second iteration, third iteration, fourth iteration, and 5th iteration. But this is not good. Okay, you wanna make sure you see that the x value in one column and the y value in one column in another way. So this is when I remove this, remove all this, and introduce you printf. Printf. Okay, so you have a quotation mark in the middle, backslash n, %s, %s. So what I want to do here, okay, this is what I want to do. So what I'm doing, let me show you. Okay, let's clear the screen. Okay, so what I want to do here, I hope I have time to explain to you. So I want to write my solution like this. So I have I as the iteration, x1 and x2. Remember, what is my x1 and x2? This is my x, this is my y. Okay, so I want to write like that. So when I equals to 1, what's my value here? When I equals to 2, what my value here? And I equals to 3, what my value here? Until I equals to 5. Okay, so you can even put a dash here to separate between the iteration and the solution. Okay, so what is S here means this %s. I have 3 column. I, x1, x2. S here to produce this character I, x1 and x2. Okay, so to produce the character, so we will say another quotation I, comma, another quotation x1, another quotation x2. So I have display my I, x1 and x2. And then, okay, you can do the line. So to do the line is mprintf /n, just create the line as long as you want. Okay, /n is to move down to one space. So I think I need it here, but I don't need it in the front, but doesn't matter. Okay. Okay, so and then to have the output, the next column here, the next column, you want to display all this result, right? So what you do, you have another mprintf. I'm just going to copy this, put it right here. Okay, now this one is the iteration I here that I want to display. This is the first column of x. This is my first column of x2. It's not character anymore. So we will say d for integer, because I is number from 1 to 5, and floating point. So your result is in floating point. Now I can put how many decimal place you want. So let's put like dot 5 decimal places, dot 5 decimal places. Okay, so let's try running this and see what you get. So press the execute button. Okay, enter the values of x, number of iteration 5. Okay, there you go. See that? We have x1, x2, and it's not arranged properly, right? So now we can fix it. It's easy to fix this. So just go to here, put 4 in the front, which means 4 space. 4 space. Okay, this is too long, so I'm just going to remove it. Okay, 2 space, 4 space, and 4 space. Dot 5 is a decimal point. Okay, let's look at your iteration here. Run it again. 5 iteration. There you go. Now I have a backslash here, that's why it's not too many backslash. So I'm going to remove one of my backslash. Maybe this one, maybe this one, maybe this one. Okay, continuing. So what we have here, I've removed all the /n so that I can have a nice looking screen. So when I press the execute button here, enter the value of x. Okay, so enter the value of x. See, you can write it like this. Should be a column vector, or you can also write it like this. Okay, the same thing. And then enter the number of iteration. Let's say 5. There you go. This is what you should observe. Okay, I from 1 to 5, x1 and x2. Now what this result tells you. Okay, let me just explain to you what it says. See, you start with the initial condition x1 and x2 with 1. So this means that I'm trying to solve this function here. Okay, I'm going to solve this two-dimensional function. So I want to find the values when the 0. So you start with x equals to 1 and y equals to 1. But you can see that the solution converged to, for your x1 value, it's already converged to 0.856. And for x2, it's converging to 0.647. Okay, so that's the root. That's the root for the solution. So you have obtained x, your solution x equals to 0.857 and y equals to 0.657. Okay, so that's your final answer. So 647. Sorry, let me just change it. 647, not 657. Okay, so that's the final solution you have obtained. You start with 1 and you end up with this answer. It's converging very quick, just 5 iterations. So you can try to run for more iteration if you have to. So if I write more iteration, just run it again and enter the x value 1 1. Let's say 10 iteration. See that? This is 10 iteration, and you know the solution already converge. Converge means the next previous iteration will give you the same value. Okay, so this is how you write a code, Scilab code, on solving system of nonlinear equation using Newton method. Feel free to email me or send me a message if you have any question regarding this. Okay, that's all for today. So hope you're gonna have a good day and enjoy. Bye.